Well, greetings, Mr. Kolazar's class. We're going to look into now reading our potential energy diagrams. Our main idea for endo and exothermic reactions is our potential energy diagrams can show whether heat is absorbed or released during these exo and endothermic reactions. Now, first off, our heat or reaction, difference in the amount of potential energy between the products and reactants. Now, our equation for this, to put into that box, shows us delta H. Delta means change in. The product's potential energy minus the reactant's potential energy. So making sure products minus the reactants is what we need to see there. So for our exothermic reactions, remember the prefix exo, chemical reaction which more energy is released than is required to break the bonds. So exothermic, think about exiting for exo, or heat is exiting or leaving. So the potential energy of the products is going to be less than the potential energy of the reactants. This is going to give delta H, meaning it's going to be a negative number since products is less than reactants. Products smaller than reactants, we get a negative number. So when we see a chemical reaction, nitrogen plus hydrogen produces ammonia plus heat. Heat is on the right-hand side of the arrow. What it's saying is that heat has been released or is being produced. It's exiting the system. Now, this is from back on page 2 of your notes. And back on page 2 of your notes, we are showing an exothermic reaction. This is our reactant, potential energy, 30 kilojoules. Our product, potential energy, 5 kilojoules. So as this reaction need to add energy in order to get the activated complex, and then we're going to release energy as we move down the graph, our difference between these two numbers, products minus reactants, gives us the amount of heat energy that's been released. So exothermic, we could do that math, 5 minus the 30 would equal negative 25 kilojoules of energy, meaning that has to be released. So there we get an exothermic reaction. Just the opposite, endothermic reaction. Endothermic, this time En to begin. Endothermic, greater amount of energy is required to break the existing bonds than is released during the reaction. So endothermic, heat enters the system. The potential energy of the products is greater than the potential energy of the reactants. So our delta H is going to be a positive value. Products is going to be greater than our reactants. So this time around, our reaction, the heat, is going to be on the reactant side of the arrow. We need heat in order for this reaction to go. So in our second diagram, the activation energy is much larger than the heat of reaction. So in the end result of this, what we need to see is that we started out down here, reactants, and we finished products up here. So this time around, when we look at this reaction, 30 minus the 5 gives us 25 kilojoules. This is going to be the heat needed for this reaction to actually occur. So we needed more energy than we actually released in this one. So an endothermic, heat's going in. Things to know about the potential energy diagrams. You will need to be able to know all of these. So make sure need to know. This will be something you will see later on a quiz. Besides that, we'll let you continue working on looking at our potential energy diagram.